A big part of the rocket science is about maintaining the momentum of the rocket. For this, we need to know the mass of the rocket at any given point in time. Let us understand what is momentum first. It is something that talks about three factors. Number one, the mass of a moving object, in our case, the rocket. So, how big or small it is, the mass. Number two is the speed at which the object moves. And three, the direction it moves towards. So, we can use the letter P to denote momentum, and to put it in a formula, P is equal to mass multiplied by velocity. So M stands for mass, V for speed, and direction, that is velocity. The momentum of the rocket depends on the thrust it gets from the exhaust. In other words, it is the thrust that gives the rocket its momentum. And where does the thrust comes from for the rocket? The exhaust. So, exhaust is the gas that comes out of the nozzle. So, this gas has a mass, it also has speed, and it moves in a particular direction. So, the exhaust too has a momentum of its own. The whole movement of a rocket is nothing but the interplay of the momentum of the rocket and the momentum of the exhaust. The Newton's second law says that the momentum is conserved if it happens in a closed system. If you take a deep space, it's a perfectly closed system because there is no other force like friction or air resistance that act on the rocket or the exhaust. There is no other external force. So it's a closed system. Hence, the momentum created by the exhaust is used completely to create an equal amount of momentum for the rocket. Momentum is not lost anywhere. But the mass of the rocket is not constant. About 90% of the mass of the rocket is fuel. So as the fuel gets burned, the mass of the rocket reduces. Look at the equation again. P is equal to M multiplied by V. So if the mass comes down, that is decreases, the momentum of the rocket will also come down. So how to maintain the momentum of the rocket? We cannot do anything about the mass. So what we can do is to increase the other variable, which is V, that is velocity. To increase the velocity, we need to burn more fuel in order to produce more gas and increase the amount of the gas exhaust that comes from the nozzle and the speed at which it comes out. This operation involves a whole host of activities, but the single most important trigger is the change in the mass of the rocket, continual change in the mass of the rocket. Hence, understanding the change in the mass of the rocket denoted as dm, where d stands for change or difference and m for mass, of course. So at any given point in time, dt is a big part of the rocket science.